Full house here today, so we're delighted to have you here with us. I think we're going to get started, and thank you for waiting. So my name is Bridget Jackson. I'm the business engagement lead at the Climate Champions team, working with the two high-level climate champions, and I'm delighted to be kicking us off today. I'd also like to just introduce you to our moderator for the day. Maddie, do you want to stand up or wave? So this is Maddie Carlsberg-Schaefer, who's going to be moderating you today as we go through the various segments of our session. And I want to extend a really warm welcome to all of you for coming in what is the second week of COP, to all of you in the room. You want the volume up? Or maybe I just need to speak closer to the mic. And also to everybody online. We had more than 50 people registered as of this morning already to join us, so clearly a topic that is of great interest to everyone. So hello to those who are dialing in from wherever you are around the world. So today we're going to be talking about climatic tipping points and how we might address those. I think we'll start by showing you a video. Would you like to introduce this, Maddie?
Yes, absolutely. Thank you, Bridget. Firstly, thank you everyone for coming today. It's a real privilege to moderate this event on a super important topic. Unfortunately, we had a technical mishap, and we had to pre-record our conversation with our panelists this morning. Those panelists will do the Earth. Oh, right, absolutely. Okay, so before that, we've got a video for you. It's actually the first time that anyone is getting to see it for public eyes. It's by Earth HQ. They produced it, and they are the media arm and strategic communications platform of the Global Commons Alliance. They call themselves a situation room for the planet. So with that, let's give it a watch. Some more technical mishaps. Ooh, yet another. We'll get there, we'll get there. We've been patient this COP. We've been patient, haven't we?
The climate emergency is all around us. Mega droughts, extreme heat, mega floods, and superstorms. The impacts have arrived earlier than many predictions, and they've hit with far greater ferocity than anyone imagined. Rising greenhouse gases are setting off a chain of events that is changing everything. Our once stable planet is starting to look unrecognizable. Every decade we fail to act, we reduce the resilience of the systems we need for our water to drink, our food to eat, our economies, and even our happiness. Every decade we fail to act, we step closer to dangerous climate tipping points. Major changes to our planet that will affect billions of people around the world. Crossing tipping points will create huge changes that will become self-perpetuating and in many cases, irreversible. How close are we to these tipping points? Research just published provides new insights into the state of critical Earth systems at risk. At our current 1.2 degrees Celsius of global warming, we are entering the danger zone for tipping points in 5 major systems. The irreversible collapse of ice sheets in the western Antarctic and Greenland. The death of equatorial coral reefs around the world, and the abrupt thawing of permafrost in northern Canada, Alaska, and Russia. This will release more greenhouse gases into the atmosphere. It is now likely that we will reach 1.5 degrees Celsius warming by the 2030s. At this level of warming, latest research indicates it is likely we could cross tipping points in 5 more systems. The slowing of Atlantic currents risks bringing harsh winters to Europe. and causes sea levels to rise along the coast of America. The Barents Sea north of Scandinavia may become permanently ice-free, further destabilizing Europe's weather. And the total loss of alpine glaciers around the world is likely. Current policies put the world on track for a temperature rise of at least 2.6 degrees Celsius by 2100. Beyond 2 degrees, we enter the danger zone for major disruption of the African monsoon and for the Amazon rainforest. Tropical forest over vast areas may die out, and the grasslands that will replace them will store much less carbon and biodiversity. If temperatures reach this dangerous level, 1/3 of the world's population could be living with an extreme heat belt stretching around the globe. That's potentially 3 billion people. Most of the impact will be felt by the poorest and most vulnerable living in already fragile states. By failing to make large emissions reductions, we are taking astounding risks with the stability of our planet and of our societies. Climate change will continue to amplify every risk humanity already faces in a way that is even more unjust. Only by rapidly reducing greenhouse gas emissions and protecting nature can we substantially reduce risk. We can and we must do this. The lives and the well-being of billions of people depend on it.
So hello. Hopefully this one is a bit better. Can you hear me okay? Very good, okay, thank you. Yeah, just bear with us on all of the sound. You still can't hear me? Okay, so bear with us on all of the sound and the AV, but hopefully a really powerful film that brings to life some of the things that we may face. And we wanted just to give you a moment to reflect on that. So if you're online, please just spend a few moments thinking about how you feel about tipping points. And if you're in the room, if you could turn to somebody next to you and share for a couple of moments how you feel about that, then that would be great. And obviously any emotion is fine. Any reaction to it is fine. No reaction to it is fine. But it'd be fantastic if you could just take a moment, pair up with someone and chat to them for a couple of seconds.
Okay. You should stand on this side. So for the camera? Okay. You have to hold the microphone really close to your mouth. And who are the organizers with you? Sorry? Who are the organizers? You need to, so the Global Commons Alliance. Okay. Okay. It's a zone and it's a conservative, no? All right. Okay.
So we'll just call you back to the room if we may. And I am delighted to introduce to you Dr. Mahmoud Mahildin, who is the high-level champion for COP27. So one of the two high-level champions that we all work with and for, and hopefully you've enjoyed some of their events this week, working hard to engage non-state actors, and he's come to give us a welcome address. So I'll pass you over to Dr. Mahildin. If you want to take that one, it's actually better. Yeah.
This one is better? Okay, thank you so much. Good afternoon. I'm very happy that you are still with great energy, even hours before the end of the COP. This is very refreshing and energizing.
and been asked to share some views on the important work. But before doing that, I'd like to thank those of you working hard in this area of work, including the Nature Zone and the Nature Conservancy, TNC, for hosting this work with the support, full support, I would say, with the Climate Champions team. There are many things that my very good team prepared to share that we know something about this issue, but we leave that to the experts. I'd like to have just a couple of areas of work on the implementation front, and perhaps building on the good work that's already happening in the finance side. So I think during the day could be useful, as I did earlier this morning, to say that nature is important. Anybody can say that. And we are harming it. Anybody can say that as well. But there are solutions that we can really be doing in terms of investment, finance, technology, and better inclusion of nature as an asset class. Asset class is being borrowed from that fantastic report by Professor Dasgupta on the economics of biodiversity. For it to be an asset class, I know that those who like nature and climate may go beyond even calling it an asset class, but that needs to be preserved, it needs to have a value, it needs to be protected, and it needs to be part of any kind of policy, regulations, investment, and finance going forward. I'm happy to see some great experiments. Some of them have been with very good involvement by TNC. I'd like to congratulate the team for the work there, because it's solving two, or actually three crises with the same tool. The recent work by TNC in countries like Seychelles, in Belize, and more recently in Barbados, on the debt reduction mechanisms. So this is a problem, dealing with debt. Investment of the proceeds into climate-related assets and nature. This is the other two crises that we need to deal with. Without the involvement, simply put, of TNC in the work, none of that would have happened, because we need a credit enhancer with knowledge on the areas of work. Good news is that the three examples, especially the one from Barbados, is encouraging many countries, including in my neighborhood here, to do something similar, to look at their debts, sovereign or with private creditors, perhaps easier with the sovereign as counterparts, and then to start doing the right work by being involved more with the conservancy kind of functions, with scientists working in this area of work, and then trying to bundle deals to debt for debt reduction and invest the proceeds in climate and nature. Sounds complicated, but it happened at a scale, and now we need it to be scaled up. Sounds complicated, definitely, without leadership, but you need really the likes of the heads of these countries to be behind it. As we saw it not very far from here, from the president of Seychelles, for the heads of government of Belize, and from the formidable Maya Motley, the Prime Minister of Barbados. So scientific solutions are there. Good credit enhancement mechanisms are in place if you want to use them, but definitely what we cannot really buy is basically leadership at the local and national level. Having said that, our job, either in the race to zero or in the race to resilience, and the work on the finance, including the work by the GFANs, is to work as catalysts to support your work and to promote it further. And this is one of the functions that we can really be helpful in, but definitely our work behind the scenes in the preparation of the work would be even, I hope, more appreciated. One final thing, one of the major outcomes from Sharm el-Sheikh is the Sharm el-Sheikh adaptation agenda, full of ideas and suggestions of projects. Many of them are related to resilience, investments, and debt reductions, but that needs some serious work. This is global, this is regional, and that needs to be taken as well at the national level. So one area of work here, perhaps you need to have a look at this piece on the Sharm el-Sheikh Adaptation Agenda, which was co-authored by the Egyptian presidency with excellent teams of experts, but with heavy involvement with our teams as well from the champions. Having said that, very grateful for this opportunity, and keep up the good work, and definitely keep up the discussions. We are here to learn from you. Thank you so much.
Thank you for making time to come and speak to us. I'm going to hand back to Maddie now to talk us through the remaining parts of the session. So Maddie, come up. It's all over to you.
Thank you so much, Mahmoud. So now we're going to be delving into more of the content that we saw in the Earth HQ video. More of those scientific issues on tipping points, the kinds of solutions that Mahmoud talked about that we're trying to address. So the panelists for that, unfortunately, we had to do a pre-recorded Zoom call because technology got the better of us. So that conversation took place this morning. That was with Johan Rockström. He is the director of the Potsdam Institute for Climate Impact Research, and he is an expert in tipping points. And also David Abura. He is the founding director of Cordio East Africa and an expert in climate and coral reefs. So with that, I'd like to introduce that video that we got.
All right, well, good morning, guys. Good morning, Johan. Good morning, David. Thank you so much for making the time to join us today. We're really grateful you can make the time. So with that, I would like to get stuck in and pick your brains a little bit. First, I'd like to start with Johan. So just in a nutshell, what is a climatic tipping point and how many are there? And yeah, just in a nutshell, what are they?
Yeah, so a climate tipping element fulfills two scientific criteria. Scientific criteria one is that they are proven to contribute to regulate the state of the climate system. And criteria two is that they have multiple stable states separated by tipping points. Push them too far and feedbacks change direction and they go from dampening and cooling to self-amplifying and destabilizing. And that's what makes them a tipping element. We've been scanning these through and scientifically advancing this for 20 years. They've come into the IPCC 6 assessment with a table of all the 16 climate tipping elements. And we published in September the most recent updates, scanning through and separating which ones have proven tipping points and which ones don't. And we've identified the 16 large climate tipping elements that today are proven to contribute to regulate the climate system.
Okay, thank you. So you mentioned that report, and it suggested, if I'm correct, that there are early signals of destabilization, and that we're reaching 5 of those 16. What is the latest status? Could you give us a bit more information on that?
Yeah, so this is the first time that we're able to get a scientific confidence range for temperature levels at which we risk crossing the tipping points. That has never been done before. And you're right, that for 5 of these 16, it's likely that we cross the physical tipping point already at 1.5 degrees Celsius. And number 1 is the Greenland ice sheet, the West Antarctic ice sheet, all the tropical coral reef systems on Earth, abrupt thawing of permafrost in the boreal zone, and the Barents Sea ice. So these are 5 big systems that are at risk of tipping over, and they would have double impacts. One is, of course, the impacts on all future generations of humans and other species on Earth. Just the West Antarctic ice sheet and the Greenland ice sheet together hold 10 meters sea level rise. This is not something that would happen overnight, but it would be irreversible. That's what a tipping point implies. You cross it and you cannot stop the trajectory in the wrong direction. So that is where we are on the assessment today of the risk. The second implication is that it amplifies warming on Earth. So if you cross a tipping point on permafrost, you get methane and carbon release. If you cross tipping points on ice sheet, they get darker, they absorb more heat, and they self-amplify warming. So it's a double risk for humanity to cross tipping points.
Okay, and I think you just touched on it a little bit, but people talk about cascades and the domino effect. Could you just clarify what that is and why that matters?
Yeah, so this is potentially the most scary part of the tipping element science. It's at the scientific frontier. It's not yet in the IPCC, but there are a number of scientific papers out there now showing that the tipping element systems are interconnected. And the most worrying one is the following, that when the Greenland ice sheet melts so fast, and remember that Greenland and the Arctic are warming 3 times faster than the planet on average, releasing massive amounts of cold fresh water into the North Atlantic. This slows down the one other tipping element system, namely the overturning of heat in the North Atlantic, the so-called AMOC, the Atlantic Meridional Overturning Circulation. This is well established. It's slowed down by 15%, well documented into the IPCC. When that tipping element slows down because of the melting of another tipping element, the green ice sheet, it pushes the whole monsoon system further south, which in turn leads to less rainfall over a third tipping element system, namely the Amazon rainforest, which can explain why we get more droughts and fires and release of carbon and loss of biodiversity in the Earth's richest terrestrial ecosystem, the Amazon. But not only that, when the whole overturning of heat slows down, you have a cascade down to the tipping elements down in Antarctica, because you get more warm, saline surface water residing more long periods in the Southern Ocean, which can explain why the West Antarctic ice sheet is melting faster than predicted. So suddenly we have a cascade between one tipping element in the Arctic, Greenland ice sheet, all the way down to Antarctica. And this, of course, leads to even more need for precaution, because these are quite unexpected, abrupt changes that can be impossible to predict exactly, but also to stop once we've crossed the tipping points.
Okay, well, that sounds a little bit scary, I'm not going to lie. But Johan, you mentioned coral reefs there, and that they're a crucial element of that overall system. And with that, I want to go to David. So how are coral reefs linked to climate change? Could you just give us an explanation there?
Yeah, well, thanks, Maddie. So coral reefs, so one of the tipping elements that Johan mentioned. So they're perhaps the global ecosystem, they're a globally distributed ecosystem that is most vulnerable to climate change. Coral reefs exist in equatorial, shallow coastal seas, so the hottest marine zones on a planetary scale. And because of their physiology, they're really at the upper temperature tolerance levels that they can withstand. So corals are really a combination of the coral itself and then a single cell algae in the coral tissue that is really an energy pump, that captures a lot of sunlight, transforms that into energy the coral can use, and the coral uses that to build its skeleton and create these amazing ecosystems. So it's like a finely tuned race car. And now that we're turning up the dial on temperature, this race car is really coming to the edge of its tolerance, and we can't drive it at that speed this whole time. We're seeing that happening in coral reefs around the world at local levels, coral bleaching events, that happen because of warm summer temperatures. They can be localized, they can be regional, and there have been 3 global coral mass bleaching events around the world now. So we're really seeing this very familiar ecosystem. We see it on the TV. Many people live beside coral reefs. They're very charismatic ecosystems. They're also uniquely vulnerable to ocean acidification, which is one of the other climate change parameters, and low oxygen. And so we're really adding all of these global threats and global change threats on top of the local pressures that coral reefs face. And so they're really at the forefront of our awareness of what's happening with climate change around the planet, because of their vulnerability and their immense value as well to for species and to people also.
Okay, thank you, David, for that. So that paints us a bit of a dark picture, but I wanted to get to why do we need to, we kind of covered that, why do we need to protect and restore them, but how can we do that? What is the main way we can protect and restore?
Well, so I think there are 3 things we have to do. So protect and restore, yes, and there's one more, which I'll come to in a moment. And that protection is that, so we already think we have lost, so Johan and I are painting a pretty dark picture about about what's happening and the challenge of things to come. But I think it's important that we really understand the scale of this, of what we have to deal with, and the scale of changes that we need to really turn things around. So protection of coral reefs, we feel we've already lost about half coral reefs around the planet, which means that, loss of species, loss of many degraded areas and so on. And that will only accelerate with climate change. So we need to work out how to protect, especially those places that will have the best chance facing climate change, but also those places that sustain people, small-scale fishers, tourism economies and things like that. We need to develop restoration techniques, a lot of research on that. I think you'll probably hear more about in the solutions phase of the session. But even more than that, we need to learn how to turn down the dial. We need to learn how to reduce the pressures that coral reefs are facing, because protecting and restoring won't protect reefs from climate change, from higher temperatures and from acidification. And we need to use this message of these immense, planetary scale tipping points to really learn how to avoid these tipping points, to recognize how immense they are and large they are. And we have to learn to avoid them rather than cross them and try to deal with them. So this is the crux of the problem. And what's really happening with corals is that a lot of the things we're doing now are like, if we continue with the analogy of the race car, you need to maintain your car, and you need to, there's lots of wear and tear that you deal with going along. And that's really what we're doing with our protecting and restoring. But we have to learn how to stop driving at full speed towards these tipping points, to slow down and to stop thinking we can just keep the accelerator down while we're doing a lot of other things, protecting and restoring. So really, this climate mitigation is really just essential for us to really work out how we need to do that. And that really means transforming a lot in our economic system and how we do business.
Thank you so much, David. So I'd like to switch from coral to ice, and for the ice, I'll go to you, Johan. I just wanted to ask, what is the role of ice in our Earth system and its relation to tipping points?
Yeah, but and just let me, Maddie, just before we go to ice, just connect the dots even further to really get David's core message ingrained here. So just to admit something important, that the tipping element science that we just talked about are the climate tipping elements, and they're assessed from a climate perspective. So we put temperature levels, how much temperature pressure do they tolerate, just as David points out. But remember the following, that if we overfish and overpollute and deforest and continue degrading ecosystems, they will tolerate even less temperature pressures. The thresholds may go down even further down. So for example, the Amazon rainforest, we assessed that a healthy rainforest, which is maintained at least at the level where it is today, can cross its tipping point at roughly 2 degrees Celsius. But as Carlos Nobres and others ecologists point out, if we continue to cut down the Amazon rainforest, we're very likely to cross the tipping point much earlier, even in temperature level. So the biodiversity and climate interactions, the race car is not driving only in high speed. We fuel it with all kinds of degrading fuels. I mean, both climate, but also overfishing, nutrient overload, and deforestation. Just to have that point made. Ice. Well, planet Earth can exist in 3 major states. I mean, either we have, as we had 50 million years ago, a hothouse Earth, the tropical planet with largely no ice sheets at all, dinosaurs on planet Earth, or you have the really, what is often described as a snowball Earth, but it isn't a fully iced Earth, but that's a deep Earth that has kind of gone down into feedbacks that takes it into an ice state. And then you have this sweet spot, what is called interglacials, which is the state that we have been in since we left the last ice age 12,000 years ago, which is a planet that has permanent ice caps in the North Pole and in the South Pole, and it has a third pole, which is the terrestrial glacial areas, and the biggest one is, of course, the Tibetan highlands. But you have permanent ice. What does this mean? Well, it's an equilibrium state. It's an equilibrium state where these caps are reflecting back roughly 90% of incoming heat, and thereby cooling the planet and creating a stable state. Now, this is therefore a system that we completely depend on to be able to have the planet in what we call an interglacial Holocene state, which is the only state we know for certain can support human development. Remember that we've been, modern humans on Earth for 250,000 years. We've lived an ice age, large parts of the time as modern humans on Earth. But it isn't until we come into this interglacial Holocene state with the two permanent ice caps, but with thriving biosphere in between the latitudes of the north and the south, that we have the ability to develop civilizations as we know it. So the ice caps regulate the stability of the climate system as we know it. But finally, I mean, they hold together something like 70 meters of sea level if you bring in both Antarctica, inland glaciers, and the Greenland ice sheet. So, they're not only regulating the temperature on Earth and the whole hydrological cycle, they also regulate the livable areas on terrestrial land areas.
Thank you so much, Johan. And also that reminder of that we're not separate to our environment as well. We're homing in on David's point as well. So just to round off our session, I wanted to ask just if there's anything very briefly that you would like to say to our audience today who are going to be sitting there at the Nature Zone Pavilion. David, if you'd like to kick that off.
Yeah, sure. Thanks, Maddie. I think the last thing to say is that I think what coral reefs will show us is that we need to have a long-term view, right? And what that means is that even we need to try and keep temperature below 1.5 degrees. If we manage that, the thing is we're not going to see the benefits in terms of the response of coral reefs for 20 years because of the lock-in of all these climate features and Earth system features. So we need to make commitments expecting to see benefits in 20 or 30 years. And that's going to be very hard, but it's going to be essential because if we don't have that long-term view, we'll never be able to deal with these tipping elements and tipping points because they do have so much inertia in their systems. We have to learn from this science, really think, 20, 30, 50 years into the future in our planning.
Thank you so much, David. Johan?
Well, it's quite simple that we have all the scientific evidence that there is no safe climate landing by only phasing out oil, coal, and natural gas. We need to get nature to not only, reduce the pace of loss, but we have to, as David points out, we have to restore and we have to, start regenerating nature so we have a capacity to buffer and dampen the stress and shocks that we inevitably will be facing, but that we also want to have as a toolbox for a stability of life conditions on Earth.
That's fantastic. Thank you, guys. So you've got a time issue, and then also it's about restoration as well. So thank you so much for that, and thank you for joining us. And yeah, that's us for today. So thank you.
Thank you.
All right. Yeah, so thank you so much again, Johan and David, for sharing their insights. So with that kind of set the foundations there. We've got tipping points, we've got various elements in the climate system, and one of which is ice, and Johan homed in on that. And he mentioned the third pole, which is terrestrial ice. So with that, I would like to invite to the stage a youth climate leader from Nepal to share her perspective on the loss of ice from her personal point of view in the Himalayas. So Shreya Casey, can I call you up to the stage? It's a pleasure to have you with us. If you'd like to take center stage, if you don't mind. So Shreya is a climate justice activist from Nepal who's seen the loss of ice firsthand. She's also a Global Choices Arctic Angel, one of over 50 incredible young women who are collaborating to pressure policymakers to act with urgency to protect our planet, with a special focus on the Arctic and Antarctic. So I'm delighted to invite her today to share her thoughts.
Thank you, Madeline. I hope you can hear me. Hi, everyone. Namaste. That is how we greet in Nepali. Let the light inside me. The light inside me honors the light inside you. So namaste once again. My name is Shreya Casey. So as you can see, I am from Nepal. Our country rich in natural resources, amazing landscapes, majestic mountains. My hometown in Solukhumbu, it lies in the laps of Himalayas and it's also home to Mount Everest, Sagarmatha, which means goddess of sky. Nepal is home to eight of the world's tallest peak. And mountains are not just a source of water for us, but it's also a integral part of our identity, and it makes us who we are as Nepali people. Over the past 24 years, I have seen dramatic changes in the climate. With more than average rate of warming in the Himalayas, glaciers has melted and made the snow covers has also melted. My grandfather, he used to trek to Dudkunda Lake, which means Milk Lake in Nepali. It sits 4,600 meters above the sea level, and it holds special religious importance to both Hindus and Buddhists. But as I said, with more than average rate of warming in the Himalayas, now there are more than before there were not too many lakes, but now there are more than 100 lakes in that area. And we, the people who live in the downstream community, we constantly live in the fear of being washed away, drowned by those glacial lake outburst floods. It does not only affect our lives, livelihood, and the hardly built developmental infrastructures, but also washes away our hopes and dreams, and also pushes a whole generation of young people backward, like me, like us, all of us. The problem is critical. And my love for my hometown, for my community, it drives me to be a part of Arctic Angel, which is a group of all women-led, all youth-led, intergenerational network where we work together to pressurize world leaders to take urgent action to protect our planet. And therefore, we have called for a 10-year moratorium, which calls to stop all the activities that impacts the fragile Arctic Ocean by banning the seabed mining, systemic test, and also gas and oil exploitation in the Arctic region. In 2019, I don't know how many of you know that, in 2019, Jakob Stoyer, please excuse my pronunciation, all of them came together in Iceland to commemorate the loss of a glacier named Okiayuk, glacier also named as Oke Glacier, which was around the age of 700. And if we see in 1890, around in the time of 1890, the glacier covered the area of 17 square kilometer. But in 1986 around, as you can see in the picture, the area was much smaller, and in 2019 its area was 0.7 kilometers. So because of that, the Icelandic Meteorological Organization had to declare, has to remove it from the glacier status, and because it is not moving and it is dead. So that is the case from Iceland. But in our home countries also, I have witnessed the loss and death of many glaciers. Unfortunately, we don't document, we don't mark the loss of glaciers in my country. But of course, I'm sure that if we go on counting, the numbers are very large, and it of course is very frightening. So I would like to invite all of you who is listening to me in this room through virtually to take this moment to reflect on the losses, on this passing, and honor all the natural places that we are losing every day, every single moment of the day, as I speak right now here. From the devastating floods in Pakistan to even heat waves in Europe to droughts in Africa to devastating landslides in Nepal, everything is connected, and I think it starts with the loss of Arctic ice. Therefore, we have to see this problem from a whole systems approach. As a youth climate justice activist, for the past 6 years, I have been doing everything that I can, from activism to advocacy to working with the decision-making table to everything. I am doing my part. So my question for you, who is hearing me here right now, is: are you doing your part? Let's work together to preserve this amazing, awesome, wonderful, special yet fragile Arctic place, and it will protect humanity at last. Yeah, thank you.
Thank you, Shreya. And if you could actually, if you don't mind, read out this letter that was on a plaque laid at the dead glacier of Ok.
Yeah, thank you, Madeline, for reminding. I'm sorry I forgot to mention this. So, as I mentioned before, when the glacier was declared dead, a plaque was unveiled, and the message written here is, I will read this message. A letter to the future. Okiakyuk, Oke, is the first Icelandic glacier to lose its status as glacier. In the next 200 years, all our glaciers are expected to follow the same path. This monument is to acknowledge that we know what is happening and what needs to be done. Only you know if we did it. August 2019, 415 parts per million carbon dioxide. Yeah, thank you.
Thank you so much, Shreya, for reminding us why we're here. This is so important. And I mean, I hope it's not all so dark. I want to shift from this, but bearing that in mind, but shift from this to, you know, what are the solutions? Can we stop glacier melt? So yes, with that, we have a presentation by Kelly Wanzer. I'd like to invite you to the stage, Kelly. Hi. Yeah. So Kelly Wanzer is the Executive Director of Silver Lining, which is a non-profit organization dedicated to ensuring society has sufficient information and options to ensure climate safety within a decade. So this presentation is a condensed version of a TED Talk Kelly gave a few years ago at the TED World Summit in 2019. So it's a pleasure to have you with us and give this version of the talk today. Thanks, Kelly.
Thank you, Maddie. And thank you, Maddie and Bridget and the Climate Champions for organizing this rather groundbreaking session here at COP, where we're talking about things that have been hard for people to talk about. I especially appreciate your comments, Shreya. It's hard to look at these things up close and to honor what's happening. So I really appreciate that. My organization is focused on near-term climate risk, and I started my journey by asking scientists questions like we saw this morning, which is, you know, what is the kind of risk that we're facing in terms of increased heat stress on the climate system? So bear with me if I have technical issues, because I'm moving my own slides here. But to remind everyone that greenhouse gases are the cause, but the immediate stress on the system is trapped heat energy. And that'll come into play in the things I'm about to talk about. And we had a really good guide posts through what's happening with that heat stress. So we know that it's causing big changes in natural systems. This is actually a chart from the paper that Johan referred to that's showing where the risk factors are in these tipping points. And what you can see, these temperature lines are targets, the Paris range, where our policies are likely to hit and where we are currently. And you can see where those tipping point risks are landing. So we have really meaningful risks in the not too distant future of crossing those thresholds. And yet, we don't have a disaster risk reduction strategy for these kinds of risks. So where I come from in the United States, we have a global disaster risk management strategy for one kind of big environmental risk, which is a large global scale asteroid collision. And we spend $250 million a year roughly. Some of you may have seen in the news that we started to redirect the trajectory of asteroids and test this. And what's really interesting about this is the odds of that kind of risk in the next 50 years are about 1 in 20,000. So we have a $250 million a year program for that risk. There's another macro risk that we have in the United States with a large supervolcano that's located in the west. We've had some meetings and we've developed an actual plan to mitigate that risk, although it's not funded. And then we have the kinds of global catastrophic tipping point risks that the scientists talked about, lots of them. And currently today, we don't have planning underway and we don't have budgets in place to look at these things from a disaster risk point of view. And what I've learned in our work in Silver Lining, where we work very closely with the UK Met Office, where some of those scientists are based, experts in the United States, is we haven't invested fully what we could in the information that we need to do a better job of understanding these risks and planning for them and preventing them. And I'm going to talk to you about some of the things that scientists have started to look at. So if you have these kind of risks in a near-term time period, and the time period that we're most worried about in Silver Lining is the next 30 to 40 years, where the IPCC projections are telling us that in every scenario for emissions, the climate system will continue to warm. So whatever risk we have today gets incrementally higher over the next 30 or 40 years, and we need faster acting possibilities than emissions reductions for addressing that. So there are a variety of things that scientists have started to look at, and there were a couple of big global assessments about them, including different ways of removing carbon from the system and different ways of removing heat energy from the system, ranging from small to big, and different ways of mitigating some of the impacts to try to protect the systems. So we're starting to see some of these being looked at in small ways. Things like putting reflective beads on the surface of the ice to see if you could reflect enough sunlight to locally mitigate what's happening to the ice. Like growing resilient coral, even genetically engineering coral to see if the coral reefs could be protected that way. But the problem that we have, and David referred to it when he was talking about corals, is a problem of scale. So people have started, Australia has a big program to try to protect the Great Barrier Reef, which you see here, and you see the different states, this sort of alarm state where you have dead reef already, you have at-risk state, and some healthy coral. But in that program, they're trying a variety of different things to see if they can save the Great Barrier Reef. But the Great Barrier Reef, in size terms, you can think about it as roughly comparable to the Rocky Mountain Range in the United States. It's huge. So the question is, what kinds of things do we have that might deal with the scale of these kinds of tipping problems in the time period that we have? So if the time period we're concerned about is the next 30 or 40 years, after which, hopefully, our emissions reductions are bringing down emissions and we're on the right trajectory, what do we have besides reducing emissions, possibly removing CO2, that could act quickly on the climate system to reduce heat if we needed to prevent some of these kinds of effects? And so scientists in the UK and the US asked these questions in their academies, and they did assessments of what the possibilities were. If you needed to reduce warming at scale in the climate system within a decade or even a few years if you had the capability. And where they landed was one of the ways that nature does this, which is the reflection of sunlight from particles and clouds in the atmosphere. This is a simulation from NASA of that effect. And what scientists have said is by increasing the reflection of sunlight from the atmosphere globally about 1%, that you could offset maybe 2 degrees of warming. And so they've looked at this question more closely. And one of the reasons that they think that is because they've observed this in nature. This is a picture of a cloud bank off the Pacific Northwest coast. The streaks you see in the clouds are produced by particles coming from the emissions of ships. And one of the things that scientists have observed is that the particulates and emissions, the things that we don't like, the dirty particulates, actually have an effect that causes the atmosphere to reflect slightly more sunlight. It does that directly, like the haze you see over polluted cities, and it does it indirectly by intermixing with clouds in ways that make them slightly brighter. This is a chart from the IPCC. Every year they have a chart like this that shows the warming effects of our emissions and some cooling effects, which you see here in blue. These cooling effects are created by what they call aerosol particles, mixing with clouds or reflecting sunlight directly. Today, scientists think this effect is happening somewhere between 0.5 degree and 1.1 degrees C. It's offsetting warming that we would otherwise see. So one of the things that I'm saying when I talk about these ideas is that a dirty, unplanned variation of reflecting sunlight from the atmosphere with particles is already happening. And so one of the things that scientists have proposed is, are there ways we could study this effect and see if it might be useful to do intentionally if we needed to reduce temperatures for a temporary period of time while we bring down emissions. So the ideas for that, a few folks have started to work on, including people in Australia, where they're trying to imitate the effect of what you saw, the streaks from ships, but using sea salt particles as mist generated from ocean water. This is an actual study that they're doing in Australia with technology that was invented in California to try to generate this type of mist. There's a huge amount of science that needs to be undertaken to understand this. So this is very early, and the study is very tiny. It's sort of, the equivalence of the emission from one ship. Now, the approach here is called marine cloud brightening. So the idea that goes with it, I don't know if I have text, let me see, I don't. The idea that goes with it is that these particles enter into clouds, they make them slightly brighter. You seek out patches of clouds where this is likely to be more effective in ocean regions. And if you were to brighten, select regions of clouds equivalent to about 4 or 5% of the ocean surface, you might be able to offset a couple of degrees of warming, in theory. And the scientists who look at this will say there's a huge amount of uncertainty, and there's an interest in studying this, but there is not a clarity as to whether or not it's a good idea. So that is one idea that they have, but it has interesting implications related to the impacts people have started to see, especially with respect to storms. So one of the things that happens if you brighten clouds, you cool the water in the air in the region of the clouds. And it might have applications for cooling the water in the air in the regions of storms. So this is an area of potential study. And I think I mentioned about the global cooling effect, and now I'm going to talk about the most prominent form of this reflective sunlight effect that scientists have proposed. And it's based on what's been observed when very large volcanoes have erupted. When the volcano Mount Pinatubo erupted in 1991, it was a big enough volcano, forceful enough, that it sent material all the way into the outer layer of the atmosphere, the stratosphere. And when it does that, the material stays and circulates in the stratosphere. And what scientists observed is that it actually had a global planetary cooling effect. This is a chart of global average temperature, where temperatures fell about 0.5 degrees C, and they were gradually restored to their previous state. And one of the things that's happened that's relevant was what they observed that happened to Arctic ice. So this is the Arctic ice record of the same period. And what you can see is that the period after the volcano erupted, there was a recovery of Arctic ice. And then as the particles fell out, the ice record gradually restored to its trajectory. So these things are now something that scientists are looking at to study as to whether or not there might be a more controlled, more environmentally friendly, and safer way that you might leverage that same capability to cool the climate for a period of time to prevent some of these catastrophic effects. I'm going to skip over this for the sake of time, and I'm going to focus on the key message with regard to this. There aren't many options for reducing warming in the climate system quickly if you really need to, because there are thresholds that you shouldn't cross, that aren't safe enough for many people on the planet to cross. This is the category that scientists have said has the most promise. And this is the area today that has the least research. And it sits in an area of uncertainty that we have about the climate system. So the really important thing that people in my community have talked about is the need for research in order to understand the processes that underlie these things, including the one that we're producing accidentally, in order to project the relative safety of what might happen with impacts with or without these techniques, what might happen with tipping points with or without these techniques. And really importantly, to provide research capacity to allow people around the world, and especially scientific experts in different countries, to have the funding and the technical capability to look at these questions directly for themselves. So that's our concern here. I'm really pleased and honored to be able to share this with you. I'll leave off by saying we're going to go into a discussion of how the world might look at these techniques and make decisions together about them. And it's a really important area of justice that we find a way to do that in a way that people can have shared information and a truly well-informed and equitable way of weighing in. One of those ways we've seen in action, I was at the meeting of the Montreal Protocol on the protection of the ozone layer last week. It's a very science-based mechanism that has been very effective in protecting both the ozone layer and reducing a form of greenhouse gases that's causing a lot of near-term warming. So we do have some examples where society can do these kinds of things well. And we're optimistic that if we produce information that we can make decisions about these things together. So I wanted to thank Maddie again and everyone here for looking at these questions, and I'll turn it back over to you.
Thank you so much, Kelly. Thank you. So if you'd like to take a seat on the second chair. All right, so lots of information, I'm sure. Some of this might be new to some of you. So with that, I'd like to introduce a panel session just to discuss some of the barriers and other considerations of these emerging technologies and just solutions in general to address those near-term climate risks. So we have, of course, Kelly Wanzer. And also, if there are any questions, please hold on to them. There will be an opportunity to ask our panelists those, any queries you may have. So with that, I'd like to introduce to the stage Vanil Narayan. Hi, Vanil. If you'd just like to take a seat wherever, yeah. Vanil is the program manager for the Investing in Coral Reefs and Blue Economy program with the UNDP Pacific office in Fiji. Also, we have Dan Badansky. Hi, Dan. He is the Regents Professor of Sandra Day O'Connor College of Law at Arizona State University. He's a lawyer by background, and he has worked on ethics and governance for climate action and interventions, such as sunlight reflection, for many years. And also we have Richard Betts. Hi, Richard. He is the head of climate impacts research at the Met Office Hadley Centre in the UK and a professor at the University of Exeter. He was actually also a lead author in the 6th assessment report of the Intergovernmental Panel on Climate Change, IPCC. He also led the technical report for the UK's 3rd National Climate Change Risk Assessment. So, hello, thank you for joining us. So, to kick off this panel, we'll be going to coral reefs in Fiji. So, Vanil, you live in the Pacific Islands and have seen firsthand the degradation of the coral reefs that David talked about. And now you run a program that works with local communities to reduce the degradation to restore the reefs. This is through coral farming and coral gene banking. We actually have a video of one of these projects. It's called ADE. It's 1 minute long. Can we play that video first? Thanks. Sorry guys, don't worry about shifting. There's been a bit too much movement already.
We have had a major coral bleaching in 2000 in which 60 to 80% of the corals died.
Coral reefs around the world are really in peril right now. I think that's acknowledged by every coral reef scientist, all of us who have been around for decades.
We need more corals. We need more coral farms. We need more coral restoration to help restore our coral reefs.
The AID project is one good example where we have the knowledge and experience, many years of experience of culturing and raising corals and repopulating reefs.
We were learning the science. we were learning what it takes to make this happen. We know now, over the 10-year period, we have learned all these pieces. Now is the time to scale it up.
Fantastic, thank you. So, Vinio, that work looks incredible. It looks arduous, however. And that video shows the scale of the work to be done. But so in terms of, upscaling that, what are the main issues to your mind? How can we really lift this off?
Thank you everyone, and I hope you can hear me. Before I sort of get into the challenges and stuff, let me set some perspectives per se. And so, for small island developing states, particularly those in the Pacific, we really don't like to be considered as small states, but largely large ocean states. And so, in particular for Fiji, in terms of the size of its EEZ, or Exclusive Economic Zone, it is the 26th largest country in the world. And it's home to, supposedly 3.52% of the world's coral reef population. And, we are home to 65,000 hectares of mangroves, and close to around 71% of our population live within 5 kilometers of the coastline. So, oceans and coral reefs and marine biodiversity is an intrinsic part of everyday life. And so what are the challenges? Before the event began, at the very beginning, we sort of were asked to get into a hurdle and talk about how we felt about that video. And I was in a little hurdle, and we were talking about, all these calamities that are there, but there's solutions as well. There are piecemeal solutions that are there, but we are facing challenges in terms of scaling up. So in Fiji particularly, one of the key things that we're working on, as you would have briefly seen in the video, is looking at coral reef planting and transplanting as well, and also coral gene banking solutions in collaboration with what we call coastal tourism operators. And so our project that I'm managing does that and more. So in particular, we're working with using public-private partnership solutions with private sector operators to help manage marine protected areas to ensure that marine biodiversity remains pristine and protected, and as well as looking at key drivers of coral reef degradation, which is looking at things like waste management and waste management solutions. So we're working on things like developing Fiji's first ever sanitary landfill that will negate open dump sites that are located next to coastal zones and cause many issues. But the issue is that there are small piecemeal solutions that are struggling to find finance and access to finance to be able to scale up. And so if you are a startup and if you are a conservation business, you really don't generate cash positive returns from the outset. And to be able to attract financing, it's extremely difficult from the local sort of landscape, because unless and until you're generating cash positive returns, the banks or local financial institutions won't even blink an eye at you. And so the idea and the intention, at least to the project that I'm managing with the Global Fund for Coral Reef and the Joint SG Fund, is to be able to give upfront catalytic financing to these transformative, promising solutions that are being run by locals, that are being run by people who face everyday challenges in terms of managing coral reef systems and biodiversity issues, and are basically in the front lines of climate change and basically experiencing all these tipping points. So the idea and the intention is to be able to, negate that challenge by providing upfront catalytic financing, but at the same time providing network connections and support to be able to scale up solutions not only in localized spaces, in piecemeal spaces in Fiji, but also in the region, and also sort of across other jurisdictions in the Caribbean, in the Mediterranean and other spaces as well. So the challenge is access to finance, access to scalable solutions, and to be able to really market these solutions that is, to be able to help them scale up, to be able to help them to become transformative rather than being piecemeal solutions that are making impact, but not at the scale at which it's enough to respond to these tipping points that we were sort of discussing. So those are the challenges. I hope I've sort of explained that a little bit. Thanks.
Thank you, Vinio. I'm just wondering, in a nutshell, how can we catalyze those flows of finance?
Sure, thanks. So what's important is to be able to understand how these projects sort of evolve, right? So you've got your ideas and great idea concepts that you have on paper, and then you have your pilot scale or pilot phase, and then you have your scale up phase. And so sort of the valley of death that is there is from your ideation all the way to your pilot scale, where you generate sort of proof of concepts that attract investors. And so there's no support from the ideation to the pilot stage. And so what we plan to do, what we do through our project, is to be able to help those transformative initiatives that I was talking to you about, to be able to access that catalytic financing, to be able to bridge that valley of death, to be able to cross that valley of death. So from ideation to what we call piloting and proof of concept, or POC, and then to be able to use that to develop bankable solutions, financing models, as well as pair biodiversity conservation with bankable revenue generation. So the idea is to be able to create business models for conservation activities. Adaptation and resilience is not financially sexy. Mitigation is, right? So if you were to choose between, let's be honest, if you were to choose between coastal protection or coastal conservation and building a solar farm, investors, if you are a genuine investor, you would straight away go for the solar farm because it has immediate, genuine rate of returns, as opposed to, say, an adaptation-centric resilience project, which would basically be seen as a social sort of responsibility or conservation responsibility. So the idea is to be able to bring out the financial business case behind conservation, protection, and also to be able to protect coral reefs as well. So we're working with coastal operators, tourism operators, etc., to be able to link business case solutions to conservation activities. And as was said by the climate champion, that you need to be able to create an asset class. So you need to be able to attribute a value to your marine conservation activities, and to be able to create an asset class that can eventually generate revenue and to be able to generate investments. So that's what we're doing. I hope that was a little clear.
No, that was fantastic. Thank you so much, Vinil. I'd just like to move from, these perhaps smaller scale climate repair initiatives towards the more kind of globally covered issues that we've talked about today. And with that, Dan, I do have some questions for you. So you have been thinking about climate interventions, such as sunlight reflection that Kelly talked about, for quite some time now. And in your work, you often describe two safeties. So very briefly, could you just tell us a bit about them and why they're relevant to this conversation?
Well, thanks, Maddie. So I've been working on climate intervention issues for a long time. And one of the things that's frustrating is I think there's a huge focus on the safety of climate interventions, and it's viewed in a vacuum. The safety of climate interventions is extremely important. We need to do a lot more research to understand what safety issues are raised by climate interventions, what types of interventions would be safest. But I think we also have to consider the other safety, which is the safety of the climate system and the potential benefits that climate interventions could provide in enhancing the safety of the climate system. We've been hearing a lot about tipping points, all of the potential risks from climate change, the potential for cascading effects. These are very scary, and we need to be thinking, in addition to the safety of climate interventions themselves, how climate interventions would enhance potentially the safety of the climate system.
Okay, thank you. So you kind of touched on it, but some people have concerns about climate intervention. But to your mind, also briefly, I'm afraid we're short for time today. What are the top 2 to 3 governance issues that need to be considered?
Well, thanks. So governance is discussed a lot in relation to climate interventions, and I think it's discussed in a very undifferentiated way. And I think we need to distinguish the governance issues raised by solar radiation management, reflecting sunlight, versus carbon dioxide removal. They raise different issues. We need to think about the issues raised by research on climate interventions versus actually using climate interventions. And again, they raise very different issues. So I think we need to think about the governance issues in a much more nuanced way. But if you had to say the 2 main issues, I think. So the first is, I think there's been a too much focus on international governance of climate interventions. And I think that's going to be very difficult to achieve. It's going to be very slow. I think the more immediate task is to develop national governance of climate interventions. There currently aren't a lot of national governance in place to address research on climate interventions. And I think that's one of the barriers to engaging in climate intervention research, is there's not a structure in place already. So I think there's an urgent need to try to develop national governance approaches to try to facilitate research. The second issue is, if we think about international governance, what's the role of international governance? One of the most prominent proposals is to prohibit research on climate interventions until we have some kind of international governance of use. And I think that's a very dangerous approach, because really it's going to be extremely difficult to develop international governance of use of climate interventions. And if we say that's a precondition for research, you're essentially saying we're not going to do any research ever. And I think that's not a good idea, because we need to understand much better the effectiveness, the feasibility, the safety of climate interventions. And I think trying to put in place international governance mechanisms that would make it impossible to do research is not a good idea. I think instead the focus should be on how can international governance facilitate research and promote it by developing cooperative research programs like under the World Climate Research Program that will promote transparency, that will promote collaboration between scientists, that will promote assessment so that research is engaged in a responsible way.
Okay. Thank you so much, Dan. So we've heard that governance for research and governance more generally are two separate issues, but I'd like to go towards that research aspect, and to Kelly, I go to you. But where is that line between research and deployment? Some people would say that research is deployment. Can you demystify or clarify that in any way?
Well, I'll point to Richard as well, because they do some research on these topics at the UK Met Office in Exeter University, where he works. But kind of where the rubber hits the road is often in these outdoor studies, like the picture I showed you in Australia. And really where, in order to understand these things, you do need to look at the highly localized effects, like what particles at what scale can you produce locally, and how do they play out right there in the local system, so you can plug that into model simulations that then tell you what the environmental effects might be. And this type of research happens today in ocean and atmospheric research, where they do release studies of toxins and pollutants so that they can get a handle on what these things might do at scale. So that level of research, that research grade stuff, is really important. But it's quite different than the kinds of things that would operate at a regional or a global scale, which would require big investments and big engineering. So there's a lot of science and research that can happen at very tiny scales that we want to do right now, so that then they inform lots of collaborative decisions about whether you build anything and do anything at larger scales.
Thank you, Kelly. You kind of touched on it in your presentation that there is some initiatives or governance initiatives already going on now. Is there, for what you just talked about, is there? Could you tell us more about what's going on in UN bodies that could have the potential to help us in this area?
Well, Dan referred to one of them, the World Climate Research Program. And a big aspect of research is looking at existing data on how clouds work, on how the stratosphere works, and then model projections of what these things might do. And those can be done in collaboration with scientists from different countries. So there's a new lighthouse effort in the World Climate Research Program, which is part of the UNFCCC, to start international cooperation among scientists, to link them together, to do more studies, like the ones I showed you, of how these things might play out in a variety of ways, how we might improve the models, how we might look at impacts. So that's one thing. Another very significant thing that happened last week was in the Montreal Protocol scientific assessment panel. They're the ones that look after the health of the ozone layer, and they've been very successful. For the first time, as I believe in a UN assessment, they have a whole chapter on these sunlight reflection techniques as they pertain to the stratosphere, the outer layer of the atmosphere, and looking at what their risks are and looking at what we might need to do to study them. So they have scientific expertise that's particularly relevant to these atmospheric sunlight reflection questions. And they're very effective at linking the science with the dialogue with their national policymakers and delegates. So those are two areas that are pretty exciting, in addition to the recent IPCC report, which Richard was very instrumental on coverage of these topics. Maybe I can give him 30 seconds to talk about that.
Yeah, thank you. So yeah, these topics have now found their way into the IPCC report. Both the key topics we've heard about in this session already are on climate system tipping points and on interventions in the climate system. There's still a lot we don't know about both of these, but a lot that we do know, and that is now starting to be covered in these reports. But as has been discussed already, we need to do a lot more research on both to really narrow these uncertainties, so we know what is happening with the climate system and what we can do about it to reduce the impacts. Yeah.
So Richard, with that actually, like, from your point of view, why should we consider climate intervention if we hope to or intend to potentially never use them?
Well, we certainly need the research and the understanding. I don't see why we would choose not to understand some of the options that we may have to deploy in the future. Obviously, the priority is to reduce global emissions of greenhouse gases urgently, and that's beyond question. It's also a priority to adapt to the climate change that is already happening. As we saw in the video to start with, changes are already happening and changes are already underway. We need to be adapting to those. But we don't know the true consequences of what will happen if we continue to keep putting greenhouse gas emissions into the atmosphere. We're clearly not reducing them fast enough. So we do need to understand other approaches. This research is really important. I think it's probably fair to say most people would say if we could just reduce emissions, fine. We probably don't want to have to be doing other interventions, but if it comes to it, we need to understand how effective they will be, how they will interact with other things going into the climate system. So I think the research is absolutely critical. Yeah.
Thank you, Richard. With that, I'd like to open it up to the audience. If you had any questions, we've got a line of experts and leaders in this field. So please, hands up. Yes, thank you. Hi.
My name is Hasna Modul. I am an IUCN counselor, and very pleased to be here, and thanks everyone. This is an ongoing process. We don't have permanent solutions. We are just going through indicators only. Now, with a solution, we have already discussed, nature-based solutions will have positive effect. If not, it will be slow, but it will be definitely more positive than other interventions. And also, certain areas cannot be, for example, coral reef you cannot regenerate, mangrove you cannot. You can have a mono forest, mono mangrove, you can have a mono coral, but you cannot replicate the real useful ancient forests or coral reefs. So to keep that in mind, I would think that we should have a moratorium on development in these very fragile ecosystems, including Nepal, Antarctic, Arctic, and it should be absolutely respected by all states who want to control and develop, particularly mining and in deep sea. So that there we can make a start. Stop pollution, stop human intervention immediately. Thank you.
Thank you. Do any of our panelists have a response? Kelly?
Well, I'll take a quick moment to say thank you for that, because I think the scientists in the beginning talked about, the stresses on the system are compound. And so we buy ourselves more time if we relieve some of the other stressors coming from development, from pollution, and so on. So I appreciate your point with these delicate systems that are close to the edge now. How do we keep them from tipping points? One of the ways is we have to alleviate whatever stressors we can.
Thank you, Kelly. I'd like to take, if there's time for 2 more questions, I can take them together and then switch over to the panelists. Who else, did anyone else have their hand up? I saw a few hands. All right. Last call. Oh, we've got one over there, actually. Hi.
Thanks. Sorry, I had to stand up.
No problem.
It was painful to sit down all the time. I thought this was really excellent and thought-provoking, but I'm still struggling to answer the question, which was something I think you said and David Obura, which was we've dealt quite a lot with the question of finance and policy, but there's still this question of scale. So a lot of what we've seen, and I'm based in Africa, and so I deal quite a lot with the question of scale on a huge continent, is still incredibly small scale. And I just wonder if there are any brief comments about that, or should we be much more honest and say with the current approaches we've got, especially in the nature-based ecosystems, we need to acknowledge that we're not, scale may not be possible. Please comment.
Thank you.
Well, I say this is one argument in trying to understand all the possible options. We don't know which ones can be scaled up effectively. As Kelly showed, there's many things that are being studied at the moment. Some of them may work at scale, some of them may not, and we don't really know. So again, we need to look at all the things and understand which ones are potentially a goer.
I guess I would say I think we really do need to understand the safety and feasibility so we can assess the different options. Some of them, I think, could be scaled fairly quickly if they prove to be safe, effective, feasible, such as ocean fertilization. So if ocean fertilization proves to be effective in sequestering carbon in a permanent or long-term fashion without harmful effects on the marine ecosystem, I think that could be scaled. I think the problem is we're not doing enough research to be able to answer those questions so that we know which of these different approaches is going to be the best to pursue.
A quick point for me is that you need to be able to answer the question: why isn't your solution scalable? Is it not technically viable, or is it not financially viable, or both? And so from our end, the things that we are doing in Fiji, we want to be able to depend a large amount on R&D and research and development to be able to back up, the narrative we put to potential investors to be able to help to scale. So a lot of times we see that there's this different narrative about conservation and protection and nature-based solutions, which is pretty much oblivious to investors and financial solutions and financial dialogue. So we speak the different languages. So the idea is to be able to bridge the divide by using research and also by using what we call financial brokers that help to bridge the language divide. So is it a technical issue, or is it a financial issue? And if it's both, then there are solutions, and we're actually doing that in Fiji. We have this target to be able to invest about up to $10 million Fijian in US dollars into the solutions we're doing, and leverage an additional 50 million to do that, to be able to scale up. So that's the sort of solutions we're working on, technical and financial.
Okay, thank you so much for your question. And thank you to our wonderful panelists. We're moving on to the last section of today. So yeah, thank you so much, guys. If you'd like to take a seat on the floor, but yeah, thank you again. So yeah. So with that, I'd like to call it to the stage Joshua Mponsam. Hi, Josh. So Josh is a Ghanaian environmental activist, and he's actually the climate lead at the office of the UN Secretary General's Envoy on Youth. So we're just going to close the session with a bit of an informal conversation. So do we ask the questions, or it just goes? Well, actually, I'd just leave it to the floor to help us close the session. Josh, thank you.
Thank you, and thanks everyone for staying through and for this very insightful presentations and conversation from Dan, Kelly. So to close up, I would say that it was very impressive to have Shreya here today. I think that was really something that we should all appreciate, and that is because most often the case studies we use to serve as an argument to do the work that we do are coming from grassroots voices who we do not get a chance to meet on an everyday basis. And that letter to the future was really powerful. And I think that when everyone read that letter, it makes you think, what can we do differently and what can we do more? So Shreya, I really thank you for being here with us, and thanks to the organizers for making that possible. I think that as a young person, as someone who works with young people globally, and working on climate change for some time, we've come on a journey. We've come on a journey where we believed that we have to mitigate significantly from day one. We knew that the way to stop the climate crisis was mitigation, and we had to do that. But we have been slow in doing that. We've been talking about mitigation for long, and every graph shows us that we are still not meeting the 1.5 degrees target. But meeting that target is really essential. And to avoid any of these tipping points, we have to meet it. Now, the good thing is that we know we can do that. And the first question that we did as part of this panel, of this event, was talking to each other about the video we first watched. And when I looked at you and we had that conversation, he asked me, what is my feeling? I said, it looks like we are being absolutely very stupid. Because we know where we are headed to, we know there are potential solutions, but we are so stuck in our own ways that acting on those solutions at the scale that matters is seemingly impossible in our head. So we have to keep talking about it, we have to keep debating about what we need to do, rather than actually doing it. So we know that 1.5 is possible, but 1.5 is not achievable without carbon removal. We have to do that. So it's about time we move away from the debate on whether to do it or not and start really thinking about how to do it and how to do it safe and how to do it well. And on that context, I will close up with two things. A, research. And I completely agree with you, Dan. We cannot do this, and the question about scale, we cannot scale something we do not fully understand. So we really need to invest significantly in research to fully understand the scope to be able to do that. So Kelly, that is an important work that Silver Lining is doing with publications and research around this to really advise and give us the guidance on this. The second part is, if we are going to do this, which we must do, the second part is the most important one to my heart, which is equity and justice around any intervention that is needed. And that is to say that the access to knowledge on this topic is currently very heavily in the global north. And if we keep going on that trajectory, it will be very impossible to have experts in the south that can advise their government, that can work together with their countries to be able to move this on a global scale. And we do not want this to be an opportunity for colonization, again, when it comes to climate solutions. It has to be a fair, equitable process that every country, every government, and significantly for those who are really on the front lines, have access to the research, the skills, the technology, and the knowledge to really help us advance on this. So wherever you find yourself, let's move away from the debate on whether to do it or not. Let's advocate for increasing research, but also increasing accessibility and equity on the knowledge on climate intervention so we can really move ahead. And if you find a high school student who want to build a career in this, you can really point them to a university close to them where they can advance their skills on this and not have to be left to the mercy of having to get a scholarship to study somewhere in the global north and might not even get the chance to do that. So hopefully we can all join in that advocacy. Thanks for having me, and thanks for a great session.
Thank you so much, Josh. So to sum up, research, equity, and justice with everything that we've just talked about, and keeping 1.5 alive as well. And with that, I'd like to hand back to our wonderful MC, Bridget Jackson.
Thank you, Maddie. And literally in 30 seconds, I just want to say thanks for sticking with us. There's still a lot of people here. I know we've run over a bit and we changed the format a little bit in order to catch up, but important topic. Really appreciate all of the comments and the good questions. Thank you to all of our speakers. Thank you to our moderator. Thank you to the Nature Zone for joining us. We would love to hear from you what you would like to say to the future. And so if you have access to Google, you can go to this link here and choose a page and write your own letter to the future, and we will collate those and use them as feedback for our program for next year. Or if you can't get access to Google, then this is my email. So I look forward to hearing from some of you perhaps with your own letter to the future and the future that we want to create together. Thank you to everyone, and also to those online for sticking with us.